Okay guys, so this is 6.3 in your math book on page 329 about making comparative inferences about population. So today you're comparing, again, inferences about populations of data. Okay, so here's your example. This one's going to take you a minute. Eli surveys a random sample of 20 7th grade students about the number of siblings they have, and the results are below. Here's the student, they name them A through T, and there's the number of siblings. To organize this data, you know what you got to do. So you need scratch paper, just letting you know. You pick all of your zeros, all of your ones, all of your twos, and all of your threes. And there happens to be somebody with a 6. And list them all out in order first. So you would put 0, 0, 1, 1, 1, 1. So you got to check it off and put them smallest to greatest first, all 20 of them. Once you do that, you can use the statistics that we know about. You can use mean, median, range, interquartile range. Remember what interquartile range is. This is the range. So 6 to 0 is a range. So the range is 6 siblings, which is true. Some have 0, some have 6. That shows the range. Okay, then this shows the first quartile of data. So in between 1 and 2, and the second is in between 1 and 2. So this is in between 1 and 1.5. I guess I should be more clear. The first quartile here in the small box is in between 1 and 1.5. And the third quartile in the other box is in between 1.5 and 2. So they're exactly the same distance apart. How do I figure that out? Also, what's the line? The line is the median. Where would the median be touching here if this is a line in our box and whiskers plot? It would be touching right between the 1 and 2, which means the median is 1.5. Well, Miss Bush, how do I find the median? Well, you put all of your numbers in a row. That's what you did. And then you found the middle. It's an even number, so is there a middle? No, only with odd. So you have to add the 2 middles and divide by 2. If you did all that correctly, then you get 1.5. Does that make sense? So you find the median by adding the 2 middle numbers. Once you have your data organized, that will give you 1.5. They say draw a model. So they did. They drew a box and whiskers plot. You know how to do that. We did a quizzes on it. How did they get the number 0 and the number 6? How did they choose that number to set up the box and whiskers plot? They found the range. How do you find the range? You take the largest number minus the smallest number. So 0 minus 6 is 6. So your smallest number should be 0. Your largest number is 6. Okay, Miss Bush, but how do they find the 2 little boxes? The first box is the first line right here. So let me get my highlighter. The first line right here on the 1 is your middle or median of your first quartile. Remember the middle box right here that's on 1.5? That's your actual median that you found in all of this data. So the first line in the first box is your Q1, which is the median of the Q1. Your second line in the middle of the box is always Q2, which is the regular median, which we decided is 1.5. And then the third line at the 2 is your Q3, which is the third median of the third set of data. Well, what do you mean first, second, and third set of data? All right, we'll have all my numbers listed out, all 20 in order. The first half of the data and the second half of the data is your Q1 and your Q3. So you should have 10 numbers in this one and 10 numbers in this one. That's where those boxes come from. If you don't remember and you need more box and whisker help, that quiz is on Google Classroom, but you should remember that Q1 and Q3 are your boxes here. Q1, Q3, and the middle line is the median of all of this data, which when you add the 2 medians, the 2 middle, you get 1.5. So there you go. This is Q1, this is Q3, That's the middle. This is the range. All right, so that's the data. That's the model of the data we showed here. And it says, explain why you chose that model. Well, because I told you to. Because I want you to get familiar with that. What else could you have done? You could have done a line plot, which I know all of you would have done because it's a lot easier. We could have put 0, 1, 2, 3, 4, 5, 6. And we could have put how many zeros there were. 1, 2. Remember line plot? Dot plot, a lot easier. You can do this or you can do box and whiskers. I need you to familiarize yourself with box and whiskers. That's why we're using that. So what data can we tell about this? Well, let's see. The whole median is about 1.5. Okay, can you have 1.5 siblings? Not so much. So you can say that most of the students had either 1 or 2 siblings. I guess 1.5 could be a baby, but not really. I'm just joking. Okay, so what else can we say about this data? How many zeros? 1, 2. 2 out of 20. So that's what, 1/10? So not many people have no siblings. We could keep looking at this data. 1, 1, 1, 1, 1. What's the mode? Remember the most occurring. 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, we got a lot of only childs here. Only childs. That's not a word. Only children. So we can look at this data. We know it's a random sample because it says it's a random sample. So that means it's a representative sample and that it's fair. They don't put the names, they just put A through T. All right, that's your Explore It. Let's move on. I'm gonna try to do all this in one video. Good luck me. Yes, that's a deer head in the background because I'm in Ben's man room because that's our office. So bear with me while I change pages. All right. I know y'all love all of these lessons on data, so you're welcome. You're welcome for that. I don't get to choose what I teach you. I just have to teach it. I liked equations better myself. But I'm not a data person, so maybe some of you are, Asa. All right, example 1, use box plots to compare populations. That's why I wanted you to use a box plot. Okay. Finn and Jonah attend different middle schools and compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend and list the data in order from least to greatest. What can Finn notice about the time spent on homework? Here's hours spent on homework each week. Different middle schools. All right. By the way, they put it in order for you. Thank you. Display the 2 data sets in box plots. Box plots. All right, here's Finn's data. How do we know what to put as the beginning and the end? Because we look at the range. What is the range of Finn's data? 11 minus 1, which is 10. And the range of Jonah's data, which is 11 minus 1, which is 10. Okay? All right. Then we have to find the median. Again, find the median by add the 2 middles. Find the median by add the 2 middles. What's the first quartile? Well, let's see. The first quartile would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first 10. Okay. All right. I'll separate it. Let me check one more time. 3, 4, 5, 6, 7, 8, 9, 10. All right. All right. So here's Q1. Here's Q3. Here's Q1. Here's Q3. What's that line? The line is the median. How do I find the median? I add the 2 middle numbers, which I blurred out. I think it's a 5 and a 5. So 5 plus 5 is 10. 10 divided by 2 is 5. And voila, the median is 5. So this is Q1, this is Q3, and this is Q2, which is the median. Okay, that's Finn's. Now let's look at Jonah's. Here we go. Q1, Q3, and add these up. 8 plus 6, 14. 14 divided by 2 is 7. And there you go. Okay. Q1, excuse my handwriting. This is hard to do in talk and video. Q1, Q3, 7. Look for relationships. The median describes the data because both data set have outliers. What does outliers mean? Well, outliers is just over here and over here, over here and over here. All right, so let's look at the data. The box is between 3.5 and 6.5. Yep, 3.5, 6.5. And the median is 5. That's Finn's. And then Jonah's, the box is between 5.5 and 8, and the median is 7. So who spends more time on homework? Overall, yeah, Jonah's school for sure. Use a box plots. That's what we're doing to compare the two. The line for the median of Jonah's data is to the right of the line to Finn's data. So Finn can say that the median of Jonah's data is greater. That's fancy words for saying, look at this line is further to the right than this line, which means they spent more hours of homework. That's what that means with a bunch of words. The box for Finn's data is longer, right? The box for Finn's data is longer. Look how long this is compared to this. So Finn can say that the data is more spread out or has greater variability. So if a box is longer like this, that means the numbers are more spread out up here. So 1, 1, 1, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4. It's going to look longer when you make it into a box plot than if it's not. So what that means is if it's more spread out, it has greater variability, which means people do homework at greater variability. Some people do 1 hour and some nerds do 11 hours. That's a greater variability than here. Only one person does 1 hour here. So they're really getting it at Jonah's school. All right, so you try it now. Kono gathers the heights of a random sample of 6th graders and 7th graders and displays the data in box plots. What can he say about the two data sets? You need to find the Q1, Q3, and median of each one, and then fill in the boxes. Sorry, my fingers are yellow. A vitamin exploded on them. Now she will pause it. You will work together to find that and move on. All right, so you should have gotten the median of the 7th grade sample is greater than the median of the 6th grade sample. The 7th grade sample has greater variability. Why? Because the box is longer. Okay? Okay. Hello again. I'm fading quickly, y'all. Have a low grade temperature, not feeling that hot, but still killing it because that's how I roll. All right, example 2. How many examples do we have today? Please not like 5 or 6. No, yay, we only have 3. 2 more left. All right, let's do this. All right. I feel like I'm talking to myself. No one's here. It's weird. Okay, Finn and Jonah analyzed the measure of center of variability and data they collected. Do these measures support Finn's assessment of the two data sets in example 1? Wow, big words. Draw inferences using median, middle, and interquartile range, Q1 and Q2 and Q3. You know that already. Just really sounds fancy. Finn and Jonah analyze the measures of center, bump, and variability. That means whose box is longer? His box is longer, right? You can see that already. Do the measures support Finn's assessment of the data in example 1? Well, what did it say in example 1? It said that Finn's had greater variability. So now 25%, 50%, 25%. Okay, that's how, I mean, hello, they're just showing you how Q1, Q2, and Q3 works. The first part of the data goes here, 50% goes here, 25% goes here. They're just showing you that there. Don't worry about the percents on there. But we're looking. The first quartile for Finn is at 3.5 right here. The median is at 5. We know that already. The third quartile is at 6.5. And the interquartile range is between 11 and 1. The interquartile range is between 6.5 and 3.5. My bad. That's the IQR. By the way, that's the initials for that, in case you forgot. The IQR. All right. Interquartile range is the distance between third quartile and first quartile. So the interquartile range is 3. And the interquartile range is 2.5 for Jonah's. Why? Because the first quartile is 5.5. The third is 8. So 8 minus 5.5 is 2.5. Told you I was losing steam. All right, so what does that say? Well, first of all, we know that this guy had more variability because his boxes were longer, right? That means the data was more spread out. So does it still show that Jonah, his 7th graders, do more homework when it's analyzed this way? Yes, nothing changes. The median of Jonah's data here, 7, is still greater. So the students at Jonah's school generally spend more hours on homework. We discussed that a minute ago. Then Finn's. The IQR, or interquartile range, IQR, of Finn's data, which was 3, right, is greater. So there's greater variability. We also know that because the boxes are longer. But we can know that mathematically by subtracting the third from the first and getting 3, the third from the first here and only getting 2.5. We can also know just by looking at the boxes and saying that they're longer. So what does that mean if there's greater variability? That means it's more spread out in the number of hours that students spend on homework. And we said that already earlier. We only had 1 person at the other school that did 1 hour. So it's more spread out. Again, same exact thing as we did before, just looking different. Okay, so how do I know, Miss Bush, if it has greater variability, the boxes are longer, or I can subtract and find IQR from third from first quartile? Okay. So I guess we're going to do a new example, not Jonah and Finn anymore, and talk about draw more inferences using measures of center. Again, saying measures of center. Measures of center mean median, because that's the center, and variability, which we just found out what that was in the last 2 examples. Mr. Bunsen, that's funny, had students grow the same type of plant in 2 different rooms to test the growing condition. The box plot showed the heights of all the plants after 3 weeks. How do the 2 populations of plants compare? So compare, that means alike or different. And what inferences, that means what can you tell about the data? Well, let's just go and look. Who has more variability? Okay, the IQR of room 7D, Q1 is 8, Q3 is 14. So what's 8 minus 14? 6. And then room 7G, you have the IQR is Q1 is 10, Q3 is 16. So 16 minus 10 is 6. So they have the same measure of variability. So you know that half the plants in 7D are between, you can look right here, 8 and 14 inches tall. That's where 50% of the data is. So you know the plants in room D are between 8 and 14 inches tall, and the plants in 7G are between 10 and 16 inches tall. So they don't have any different variability. It's all still 6 inches apart, but which one grew taller, 7D or 7G? You got it, 7G. So the answer, while the median heights, which means middle heights, are the same, both 12, the plants in 7G are generally taller. You can see that here. You can infer, fancy word, that the growing conditions in room 7G are more favorable for plant growth than in 7D. So let's think of some reasons why 7G plants might be growing more. Maybe there's more sunlight. Maybe they left a window open and they got more oxygen, or they got a little watered more than these plants. There's so many different things that could change why they're taller. But one thing you can infer is that something in the conditions in this room are different than this room. All right, cool. So do the try it. A local recreation center offers a drop-in exercise class in the morning and the evening. The attendance data for each class over the first month is shown in the box plot at the right. What can you infer about the class attendance? Morning, evening. Look at the range of variability for the evening. You have 8 and 5. So the range of variability for the evening is 3. The range of variability for the morning is 6 and 3. So it's also 3. You can tell that because the data is split. The box plots are split even in half. But what's the median in the morning time? 4.5. And the median in the evening time is 6.5. This is the attendance for each class over the month. So what does that tell you about people? They prefer evening classes. They're not morning people. No coffee. So what can we infer? Here's a sample answer. More people prefer to drop in the evening classes than the morning class. That's literally all they said for their answer. You could have thought of way better stuff than them. All right, so that's the 3 examples. Let's move on to key concept and do you know how? Do you know how? I think I dropped my tape. So we're going to do it this way. Do you know how? Dang, the answers are all up in your face. The box plot describes the heights of flowers selected randomly from 2 gardens. Use the box plot to answer 4 and 5. Find the median, find the data, press pause. Do it together as a class. Okay, you should have gotten 6 and 4. Make a comparative inference. You're just comparing about flowers in these 2 gardens. What can you say? Here's some samples. Think of your own real quick. Look at the data. Press pause. The flowers in garden Y are generally taller than those in garden Z. Okay, again, you could probably infer why that might be. Draw your own inferences from that. Alrighty, so you're going to practice in problem solving. You have 6, 7, 8, skip 9. 10 is bonus thinking. Maybe she can give you a treat in the back if you get that one. But you definitely have to do the assessment practice too. So 6, 7, 8, skip 9, bonus for a treat in the back, and assessment practice.